My dear friends, today I am going to discuss with you the magnetic dipole moment, or we can say what is the magnetic moment in short. Let us consider a circle of radius r and electron is orbiting. At the center there is a nucleus of atomic number Z. That means in the nucleus there are Z protons. With one proton, the charge is E. On Z protons, the charge is Ze. The radius vector is r vector. And when there is r vector, and because there is a velocity tangent to the radius vector, the momentum will also be along the same direction. So when there is r vector, there is a p vector. Cross product rule, okay, r vector cross p vector, you will find the direction of angular momentum vector, which is along the positive z axis. So here charge on the nucleus is Ze. As the electron is moving anti-clockwise, electron is orbiting anti-clockwise, the current will be clockwise because the direction of the conventional current opposite to that of the electron current. So current is clockwise. So whenever there is a current, and there is an area, what happens then? The question, very important question. So first of all, electron revolving around the nucleus in anti-clockwise direction. So this electron mean current is clockwise. So clockwise current is orbiting and there is an area. So tiny current loop behaves like a tiny magnet. As I is there, A is there. Now what about the direction of the A vector? You can find the direction of A vector accordingly as the current is circulating. As the current is, clockwise, the area vector will be, by applying the right hand thumb rule, you will find area vector along the negative z axis. Okay, apply the right hand thumb rule for finding the direction of area. Curl your fingers according to the direction of current. So it becomes a tiny magnet, small magnet. Remember, like this is north, and put the arrow like this, and now the arrow shows the direction. Which direction? Anti-clockwise. So anti-clockwise current behaves like north pole. So south pole, put the arrow, join the arrow. Now the arrow shows clockwise. So clockwise circulations behaves like a south pole. So anti-clockwise north, clockwise south. Now in our case, current from the above, if you see the loop from the above, then it is, clockwise, means south face. So upper one is south face, lower one is the north face. And I already explained about the area vector. It is along the negative z direction. Okay. And current into area is what? The magnetic moment. What is magnetic moment? Actually, its value tells us the numeric value of the magnetic moment. It tells us that the tiny magnet, how much is it is strength wise. If strength wise it is low, the value of mu L will be low. If the strength wise it is strong, then the value of mu L will be high. So mu L signifies the strength of the magnet or magnetic moment. Now, current is charge over time. Charge is negative because electron is circulating. Velocity is distance over time, distance of the complete circle, and time of a complete circle. We find time period from here, substituting there, current becomes. So this is current. Now what is the magnitude of area? So classical magnetic moment is current into area. Area is pi r square, substituting the value of I here. So r cancels out, pi cancels. Now this is mu L multiplying and dividing by m. So mvr is what? Mvr is basically angular momentum. Very important. Now mu L becomes minus E upon 2m into L vector. Just see a negative sign. It tells us that the direction of angular momentum and direction of magnetic moment, it will be opposite, 180 degree. So it is clear from the figure also, as L is along positive z, mu L is along negative z. So negative sign also signifies the same. So opposite in direction. Now we know multiplying and dividing by h cross. Now this is the relation. Now E, h cross, 2m, they are all constants. And what the constant is called? This is called mu p, Bohr magneton. And what will be its value? N units. The value of mu p is numeric value, or it may be written in the other units. Now just see, what is Bohr magneton actually? The angular momentum, what's the magnitude of angular momentum? It is related with the orbital, quantum number, L into L plus 1 into h cross. What is L? This orbital quantum number. Now substituting the value of L magnitude here in our case. So Bohr magneton, the mu L becomes Bohr magneton, then L magnitude divided by h cross cancels out. So this value becomes the magnetic moment. Now why this small l? It is because this magnetic moment is because of electron is orbiting around nucleus, not because of the spinning. There is contribution to the magnetic moment because of spinning, but here I am discussing with you only the orbital magnetic moment. Bohr magneton root of L into L plus 1. Sometimes we attach a G factor, where G in our case it is 1 and the value is same. Now a question for you. The question for you, what is the use of G factor here? Okay, Second, what is the basically Bohr magneton? Of course, it depends upon the orbital quantum number. Okay, so there are the two questions for you. The physical significance of the Bohr magneton, and second, what is the significance of the G factor? Okay, why it is attached here? As its value is 1, there was a use of it. So please write me in the comments box. Okay, second, my suggestion, you do yourself for magnetic moment because of the, as the electron spin about its axis, and you drive that relation and then see what about the formula for magnetic moment because of the spinning. Okay, thank you.